Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 3 from the June 2022 Statistics S1 International A-level paper. And this question here is about this frequency table. It says Jill buys a bag of logs to use in her stove. The lengths L centimeters of the 88 logs in the bag are summarized in the table below. So here you have a frequency table, a grouped frequency table, which tells you the number of logs between particular lengths. So the logs between 15 or greater than 15 and less than or equal to 20 centimeters, there's 19 of them, and 35 between 20 and 25 centimeters, and so on and so forth. So it says a histogram is drawn to represent these data. The bar representing logs with length 27 to 30 has a width of 1.5 centimeters on this histogram and a height of 4 centimeters again on the histogram. So first thing we're going to check for is, are there any gaps in these limits? And there are no gaps. 15 to 20, 20 to 25, 25 to 27, and so on. Okay, so we're asked to calculate the width and height of the bar representing the log length of 20 to 25 centimeters. Okay, so we've got the bar widths. Okay, we got the categories first. I'm going to write the 20 to 25 category first. This is what we have to find out about. I'm going to deal with the width of the bar and the height of the bar. Okay, and we have also the 27, sorry about that, that's less than, to 30 category. Now, we have to find the width of this bar. Okay, now we know that the width of the bar, of the interval, the width of the interval of the 20 to 25 is 35. Is 5. The width of the interval is from 20 to 25. So this width is representing 5 units. And we know that the 27 to 30 bar, okay, 27 to 30 bar has a width of 1.5 centimeters, and it's representing 3 units. So we know that 1.5 centimeters represents 3 units. We want to find how many centimeters the width of this bar is going to be. So this is proportional. So we can be able to find what W is quite easily by using cross multiplication. We can say 1.5 times 5 over 3, and that will give us our answer. So you have 1.5 multiplied by 5 divided by 3, and that gives us 5 over 2, which is 2.5 centimeters. And that makes sense. Okay, yeah, so that makes sense. This is going to be larger than that by that ratio. Okay, now the height of the bar is determined by what's called the frequency density. The frequency density. Okay, now the frequency density is given by the frequency divided by the interval. So the frequency density of this bar here is 35 divided by 5, which is 7. And the frequency density of the bar that we know about, its height is 5 divided by 3, which is, 15 divided by 3, which is 5. So this is 35 divided by 5, which is 7. This is 15 divided by 5, which is, 15 divided by 3, which is 5. So I know that the height of the bar is determined by the frequency density. So the height of this 20 to 25 bar, okay, we know that the height of the 20 to 25 bar, that's what we have to find. So the height is that we're going to try to find is going to be representing 7 units of frequency density. And the height of the bar that we have been told about, which is the 27 to 30 bar, it tells us the height is 4 centimeters. So we see that 4 centimeters height is representing a frequency density of 5 units. So we can again use cross multiplication to find what the height of this bar is. It's going to be 4 times 7 divided by 5. So you're going to have 4 times 7 divided by 5, which is 28 over 5, which is 5.6 centimeters. Okay, so that's the width. The width of the bar that we need is 2.5 centimeters, and its height is 5.6 centimeters. So there's the answer to part A, using proportion. It's quite a common type of question. Then part B says use linear interpolation to estimate the median of L, the median length of this. Okay, so the median length is the middle value when they are arranged in order of size. Now we see that there are 88 logs in this set of data, but it's grouped data. So whenever we have grouped data, we want to find the median, which is Q2. We can find the position of Q2, not the value. The position of Q2 is going to be by the number of entries divided by 2, which is 88 divided by 2, which is 44. Now, as this is grouped data and we don't have the actual values, we don't have to do anything else. Like if it was discrete data and we knew all the frequency wasn't grouped, then what we would do is we would say, okay, 44 divided by 2, so 88 divided by 2, 44. So we're going to take the next, we're going to take that value and the next value. It's an even number of entries. We'll take that value, the 44th and the 45th value, both of those together would be the median. But in this case, we have group data. We don't have any accuracy. We don't know the exact values of any of these entries. So all we do is we see we're looking for the 44th position, whatever that's going to be, and we have to use linear interpolation to find it. So what I like to do here, we're looking at the 44th entry. So if we look at this, we got 19 and then we got 35. So 34, 5 plus 19 is like 54. So we can see that the 44th entry is going to be somewhere in this group here. By the beginning of this group, by the end of this group, sorry, and the 19th, the beginning of this group, you're the 19th entry. By the end of it, you're the 54th. So we can see the 44th entry is definitely in the group 20 to 25. So what I'm going to do is, so that we can say in the group 20 to 25. Okay, so what I'm going to do is I'm going to make a little bar here to represent our position, our value, which is on top, so it's between 20 and 25, and somewhere between this is Q2, the median, the value, that's what we're looking for. And we know that at the beginning of this group, we're on the 19th term. By the end of this group, we're on the 54th term. And we're looking for the 44th term. So in total in this group, as we see, there's 35 entries. Okay, there's 35 entries in this group, as we can see from here. And we're looking for Q2. So Q2, we can use some sort of proportion. We can say it's going to be more than 20. So it's somewhere between 20 and 25. How far along this bar is it going to be? Well, it's going to be the same proportion that this 44th term is, compared to that 19 over the width of that bar. So it's going to be 44 minus 19, that distance, the fraction that gives with the width of this bar, which is 35 in terms of its position. That's the fraction of the value between 20 and 25 it's going to be. So the distance between here is 5. So this fraction here will tell you how far along this bar Q2 is going to be. So it's going to be 20 plus, and we're going to have our 44 minus 19 divided by 35, and that's multiplied by 5. So it's going to give us 165 over 7. Okay, so that's like 23.5714. 23.5714. They didn't tell us how to round it, so we'll round it to 3SF. So therefore we can say that the median is equal to 23.6 centimeters. Okay, that's the way they gave everything. No, they haven't actually, but no. As there's no mention of how to round it, we should round to 3SF. 23.6 centimeters. Does that make sense? Does that look sensible? Yes, it does. Somewhere between 20 and 25. Okay, so there's the answer for part B, using linear interpolation to estimate the median value of L. Then it says the maximum length of log that Jill can use in her stove is 26 centimeters. Jill estimates using linear interpolation that X logs from the bag will fit in her stove. Show that X equals 62. So she can only use logs up to 26 centimeters in her stove. So she can use these 19 and these 35, but from these, she can't use all of them. How do we use limit interpolation? Well, we see 26 centimeters is halfway. It's halfway between 25 and 27. So a half of this 16 is what she needs. So we could maybe, if you want, it's only worth 1 mark. So all we need to do is show that it's 19 plus 35. Those are all within the length. Now from the next group, half of the logs, we assume half of the logs are within the length because that's the only thing we can do. We don't know the values of these 16 items, so we just assume that they're evenly spread along here. So we can say that 8 out of these are going to be in the length that we require. So we're going to say plus 16 over 2, and hopefully that will give us the correct answer. So we have 19 plus 35 plus 8, 16 over 2, which gives us 62, and that's exactly what we have been asked to show. Okay, so that we know that we're on the right track. So it's only worth 1 mark, so no need to go into any more explanation from that. That's pretty simple. Okay, 26 is halfway between those two. We assume that these 16 are spread evenly, so we take a half of that 16, which is 8. These two categories, those numbers are within the length which will fit in her stove, and the ones above that are outside of the length that will fit her stove. So those are the ones that we need, and we can see that gives us the value that they're asking us to find, which is 62 centimeters. Okay, so that's part C done. Okay, now for part D. It says Jill randomly selects 4 logs from the bag. Using x equals 62, find the probability that all 4 logs will fit into her stove. So basically what they're saying here is there's 62 logs which can fit into the bag and so into her stove. So out of these 88, remember there's a total of 88 here as we were told in the beginning of the question. There's 88 of these logs altogether. 62 of them are of the size that will fit into her stove. So the probability that 4 logs that she picks from the bag will fit into her stove. So the probability that the first log will fit into her stove is going to be 62 out of 88. And the probability that the second log will also fit into her bag is going to be, well, there's 62 logs that fit into the bag before. 1 has been taken out, so there's 61 left out of, there's 87 left in total. And you pick a third log, there's only 60 logs left out of 86. 60 logs which are of the correct size out of 86 logs altogether. And the fourth log, when we pick that, there's only 59 now left out of the total, which is now 85, because you've picked 4 logs now. All right, so you got 62 out of 88 for the first pick, 61 out of 87 for the second, 60 out of 86 for the third, and 59 out of 85 for the fourth pick in a row. So now we're going to find what that gives us. So we can take our calculator and just stick that into the calculator. So we have 62 over 88 multiplied by, I'm going to have 61 over 87 multiplied by, I'm going to have 60 over 86, and that's going to be multiplied by 59 over 85, and that gives us 0.23922. It goes on, so we'll just leave it at 0.239, 0.2392224, and so on. So we can see, rounding to 3SF, this is going to give me 0.239. That's the probability that all 4 of the randomly selected logs picked from the bag will fit in her stove. So there's part 3, question 3, part D. Okay, now for part E of this question. And here we are told that the weights in W in grams of the logs in the bag are coded using y equals 0.5 W minus 255 and summarized by the following summary data. We have n equals 88, as we know there's 88 logs in the bag. But here what we have is the sum of all the y values. So basically all the weights of the logs, okay, which are not given in the original table, that's about the lengths. The weights of the logs are taken and the weights are multiplied by 0.5, and then 255 is taken away from those values. And so you have your W values, then you have your coded values, which are called Y, which basically whatever W was, you halved it, multiplied by 0.5, and took away 255 to give you the coded values. Then these coded values were added together, and that gave you the sum of the Y values. And then you had Y squared. So these Y values, these coded Y values were squared and then added together, and that gave you the sum of Y squared. So that's the sum of Y squared, and this is the sum of Y. Okay, so that's what's happened here. So we've got the summary data not for W but for the coded values, which are Y. So we've got to use this to find the actual real mean of these logs in the bag, the mean weight of them. Okay, so what we can do first is we can find the mean of Y. So we can find the mean of Y from the data that we've given. So we can say the mean of Y, which we're going to call Y bar, is equal to the sum of the Y values divided by the number of values, which is 924 divided by 88. That's the mean of Y. So the mean of Y is equal to 924 divided by 88, which is 21 over 2, which is the same as 10.5. Okay, that's the mean of Y. We have to find the mean of W, which I'll call W bar. Okay, now we know in this coding here we've got multiplication and subtraction. Now let me take a set of simple data just to illustrate. If I have the numbers 1, 2, 3, and 4, and I was to add 1 to each of these data entries, this would become 2, this 3, and this 4, and this is a 5. A simple type of coding just to illustrate. Now, adding 1 to each of the data entries, of course, is going to change the value of the mean. The mean right now is 2.5. Here it's going to become 3.5. Okay, it's going to increase by 1. And similarly, if I take away 1 from each of the data entries of these original ones, I'll have 0, 1, 2, and 3. Again, what's going to happen is the mean is going to get less. It's going to get less than 1. And if I multiply each of these data entries by 2, the original ones here, I'll have 2, 4, 6, and 8. Again, the mean is going to increase. It's going to be doubled. Here was 2.5, now it's 5. And similarly, if I was, for example, to multiply by a half, divide by 2, you could say, you're going to end up with 0.5 and 1 and 1.5 and 2. So again, the mean is going to be halved. It's going to be changed. So addition, subtraction, multiplication, division all have an effect on the mean. So when we have a coded mean, if we want to transfer it or change it into the actual mean and you have to undo the code, we have to take into account all of the operations, addition and subtraction and multiplication and division. So what we have here is we have the coded mean. So we know that that's 10.5. And that's equal to 0.5 times the mean of W minus 255. So I must add 255 to the 10.5 and divide by 0.5, and that's going to give me my mean of W. So I take my 10.5, so I'm going to have the answer, which was 10.5 plus 255 divided by 0.5, and that gives me 531. That is the actual mean, 531 grams, the actual mean of the weights of the logs in the bag. Okay, so that's the answer to E part 1. Okay, now for E part 2, they're asking us to find the variance of W. Okay, now the variance of W. Now what we have here is we have everything in terms of Y again. Okay, so we have the Y values. So we can find the variance of Y from this data, the variance of Y. Now we know that the variance is basically the mean of the squares minus the square of the mean. So the mean of the squares is going to be all of the values squared and added together divided by the number of entries, which is going to be the sum of Y squared over N. And the square of the mean is going to be the mean, which we found up here. Well, it's basically this, the sum of the y entries divided by n and squared. This is the variance. This the mean of the squares minus the square of the mean. So that's going to be given by 12,862 divided by 88 minus 924 divided by 88, but that has to be squared. That will be the variance of y, the variance of y. Okay, so what we do is we take this and we say 12,862, oops, not 11,000, 12,862 divided by 88 minus, and that was 10.5 exact value, so I can use that squared. Okay, I can put this fraction in, but I know it's exactly 10.5, so no problem. If that 10.5 had been rounded, then I would use this exact fraction, but this is was exactly 10.5, so that's fine. So that gives us 395 over 11. I'll leave it in this exact form for now until the last step, because now we want to find the variance of w. Okay, we want to find the variance of w. Okay, that's what we have to find. We've got the variance of y, so we have to deal with coding of this data now. Now we know that the variance of, or we know we can say that that y is equal to 0.5 w minus 255. So therefore the variance of y is equal to, so the variance of y is equal to the variance of 0.5 w minus 255. Now, with variance, when we've got coded values, what you have to be careful of when you're dealing with coding is that the addition and subtraction does not affect the variance. Why is that? Because variance is the square of the standard deviation. And if we go back to these data values here, the variance is the square of the standard deviation. And the standard deviation tells about how spread out the data is. Now, if we were to add 1 to each of the data entries like we've done here, okay, the original range of this data is from 1 to 4, which is 3. When we added 1 to each data entry, the spread of the data still stayed as 3, from 2 to 5, which is also 3. And we subtracted 1 from each of the data entries. The range of the data also did not change. That means the standard deviation will be the same because it's a measure of how spread out the data is. And if the standard deviation remains the same, therefore the variance remains the same. That means that any coding which involves additional subtraction will not change the variance. So it does not have to be taken into account when we are undoing the code. But if we multiply each of the data entries by 2, you can see the range changes from 3 to 6. 8 minus 2 is 6. And if we divide each of the data entries by 2, then we can see that the range changes from 3 to 1.5. So multiplication and division do affect the standard deviation, therefore they do affect the variance. So when we are dealing with something like this, we can say that the variance of y is equal to, now what I can do is I can ignore the minus 2.5 part, and what I can do is I can take the 0.5 part. Because the variance is the square of the standard deviation, I'm going to square the 0.5, and this is times the variance of w. And what we have to find is the variance of w. We already know the variance of y, so I'll just do it over here. So we can say that the variance of y is 395 over 11, and that's equal to 0.5 squared times the variance of w. So we can take this value and divide it by 0.5 squared. So we can say the variance of w, which is what we have to find, is equal to 395 divided by 11. And because we're going to divide by 0.5 squared, that will end up in the denominator here. So we can then write down the variance of w is equal to, so we've got this value here, we could just divide that by 0.5 squared, divided by 0.5 squared, and that gives us 1,580 over 11, which we can round to 3SF, which gives you 144 to 3SF, 144 to 3SF. Okay, that's the variance of W in this question. Okay, so that's the variance. Okay, so that's the answer to part 2 for question 3E. And that concludes this question. I hope that was clear. In the last part, the mean is affected by both addition and subtraction. So when you're uncoding the data, you have to incorporate both of them. The variance is the square of the standard deviation. Standard deviation is not affected by addition and subtraction, only by multiplication. So the multiplication part, we have to decode that part. And as the variance is the square of the standard deviation, we have to square that multiple of W in order for us to uncode the data. So there we have the answer. Thank you for watching. Other questions from this particular paper can be found in the playlist, which will appear somewhere in this region here. Other questions from this topic, which is to do with, I guess, analysis of data and frequency tables and so on, will be found in the playlist, which will be over here. And you can subscribe to my channel by clicking on this link. Please check out the links in the description for other units you might be interested to, and also if IGCSE material that you might, or you know somebody who might benefit from. Thank you for watching, and see you soon.